contains 7 topics. Only three of topic is for me: cutting operation, bending operation, and drawing. In sheet metal, the definition of sheet metal working is cutting and forming operation. Generally, sheet metal is zero point 0.4 mm to 6 mm in thickness. Operation usually performed in cold working. For low carbon steel, the carbon contains 0.06 to 0.15%. Here is some application for sheet metal working in automobiles, truck, airplanes, railway cars, and locomotive, farm, construction equipment, small and large appliance, office furniture, computer and office equipment. There are some advantages in sheet metals as high strength, good dimensional accuracy, good surface finish, relatively low cost for large quantities, economical mass production operation are available. There are some terminology in sheet metal working: punch and die. This is tool which is used for cutting, bending, and drawing. Stamping press. It also a machine. Stampings, that means sheet metal products. In sheet metal process, there are three major categories: cutting, bending, and drawings. First one picture that relates with cutting. It is just before the punch contact the work. T is the thickness of the um, work metal. This is the second picture for punch begins to push into work, causing plastic deformation. This is for punch compression and penetrates into work, causing a smooth cut surface. This slide for fracture is initiated at opposing cutting edge which separates the sheet. In this slide, this is the metal, work metal, and the area of upper area roll over, the middle one varnish, and the last one is fracture zone. Uh, in the last zone here is the bars. Shearing, blanking, and punching, three principal operation for pressing work. Shearing, along a straight line between two cutting edges is used shearing. Typically, it is used for large metal to cut into several segments, smaller segments. Upper blade is inclined. Here is a picture for clear view. Blanking. Blanking is one kind of shearing, but um, sheet metal cutting to separate piece from surrounding stocks. That is called blank. A blank is the desired part. A picture shows that thing. Punching is similar to blanking, but the desired metal is the surrounding stock. To cut something, there will some clearance between punch and die. It is between 4% to 8%. Here is a recommended equation for clearance. C is equal to AT. A is equal to allowance. T is equal to stock thickness. C shows the clearance. There is a chart for three sheet metal groups for allowance. For blanking, a round blank die punch diameter is equal to dB minus 2C. C is equal to clearance. For punching, a round hole of diameter ds, whole punch diameter is equal to dh whole diameter is equal to dh plus 2c. For better cutting, there will require a angular clearance for dropping slug or blank easily. The typical values of slug angular clearance is 0.25 to 1.5 degree. For cutting, there is a equation for force, compressing force. F is equal to STL, S shear strength of the metal, T is stock thickness, and L is equal to length of the cut edge. If shear stress is unknown, then the equation will be F is equal to 0.7 TS TL. Here TS is equal to ultimate strength of the metal. There are several picture for cutting operation like cut off, parting, slotting, perforating, notching, semi-notching. Trimming. Trimming is a cutting operation performed on form part to remove excess metal to an established size. If if a very small clearance to obtain accurate shape, there is use shaving. Fine blanking is a shearing operation used to blank sheet metals parts with close tolerance and smooth straight edge in one step. To bend metal, to bend a straight metal into a regular band, there is use bending. Metal on inside of the neutral plane is compressed while metal outside is stretched. There are used to bending process, B bending and edge bending. B bend performed with a V-shaped die, edge bending performed with a whipping die. It is in used cantilever loading of shear metal. There are some advantages for V bending for low production or performed on a press brake. B dies are simple and inexpensive. In edge bending for high production and pressure pad required, die are more complicated and costly. If the bend radius less than stock thickness, there will have a stretch during bending. Band allowance formula is equal to AB is equal to 2 pi alpha 360 R plus KBAT. KBA is a factor. Estimate the stretching. T thickness R band radius alpha band angle. R less than 2T, then KBA is equal to 0.33. R greater or equal 2T, then KBA is equal to 0.50. Spring back. Increase in incline angle of band part relative to included angle of performing tools after tool is removed. As there is elastic energy remains in band that is occurred. Two methods are used for compensating this spring back: over bending or bottoming. This is the equation for maximum bending. Here T is equal to tensile strength, W is equal to part width in direction of band axis. T is stock thickness. For B bending, KBF is equal to 1.33. For H bending, KBF is equal to 0.33. This is the clear view for die opening dimension D. A is V die and B is whipping die. There are some bending like hemming, seaming, curling. channel bending, U bending, air bending, offset bending, corrugating bending, tube forming. The last topic of this presentation is drawing. Sheet metal forming to make cup shape, box shape, hollow shape drawing is used. In this process, sheet metal blank is positioned over die cavity and then punch pushes metal into opening. There are several stages for drawing, like punch just before contact with work, bending, straightening, friction, and compression. The last one is final cup shape, showing effect of thinning in cup walls. In drawing, the drawing clearance is C is equal to 1.1 T. Clearance about 10% greater than stock. In drawing, dr is the thickness drawing ratio. Dr is equal to dB by dp. dB is equal to blank diameter and dB is equal to punch diameter. Dr upper limit is 2. In drawing reduction, R is equal to 1 minus 1 by dr. The thickness of starting blank divided by blank diameter is equal to T by dB. Here is the equation for maximum drawing force. In this equation, T is equal to original blank thickness, Ts tensile strength, dB and dP the straightening blank diameter and punch diameter. There is a equation for holding force. Holding force is equal usually about 1/3 of the drawing force. For final dimension of drawn shape to correct straightening, starting blank diameter dB must be right. Solve for dB by settings starting sheet metal blank volume is equal to final product volume. To facilitate calculation, assume negligible thinking of part wall. There are two pictures for redrawing of a cup. Here, two picture for reverse drawing. Other sheet metal forming operation performed on conventional presses, operation performed with metal tooling and performed with flexible rubber tooling. This slide shows the drawing without a blank hole. Here is some uh, common defects for in drawing. Wrinkling can occur either in the flange or in the wall. See the tearing and de-earing E surface stretch. That's all, sir, from my side.
Okay. Is there any thank you slide? Russell?
No, sir. As the contents, yes, sir. This cover the last 4 topics covered by the another.
Yes. Okay. So nobody asked you any question so far. So do you have any
I have a
question,
question, sir.
participants? Yes.
Sir,
Yes, of course. Go ahead.
sir, স্লাইডে ছিল 0.4 mm টু এই 6 mm পর্যন্ত বলছে শীট। আমার একটা
0.4
প্রশ্ন
mm
হচ্ছে
0.4
mm টু
mm.
6 mm।
জি স্যার।
Okay.
এখানে প্রশ্ন হলো শীট, তাহলে 0.4 mm এর নিচেও শীট আছে, এর উপরেও আছে, তাহলে এগুলোকে মানে শীট আর হচ্ছে প্লেট এর ভিতরে ডিফারেন্সটা কি?
If the thickness more than 6 mm, that is called plate.
And what happens if the thickness is less than 0.4 millimeter?
Actually, I do not know what is called if the thickness is less than 0.4.
0.4 থেকেও শীট নিচে শীট আছে, সে গেস শীট বলে সেগুলোকে আর কি।
They are also sheet. Okay? If it is less than 0.4, where did you get this information? Is between 0.4 to 6 millimeters. Did you follow any book?
Yes, sir.
Which one?
Sir, the book is given by you.
Okay, that means
At that moment, I have no, don't recall the name of the book.
okay, yeah. Always. I think below 0.4 millimeter, those are also sheets, but usually less than 0.4 millimeter, they're sometimes called film. Okay, rather than sheets, sometimes they're called film. And maybe that is why they have mentioned 0.4 is one of the threshold point for sheet metal. Okay.
Yes, sir.
Okay. Any other question?
স্যার আমার একটা কোশ্চেন ছিল স্যার।
Yes. Of course. Go ahead.
স্যার এটা হচ্ছে আপনার যে প্লেট, যেটা আমরা কত পর্যন্ত আমরা প্লেট কাউন্ট করব, কত মিলিমিটার থিকনেস পর্যন্ত?
Yeah, are you talking about the maximum thickness or minimum thickness?
না, মিনিমাম থিকনেস।
Um, I don't think there is a limit, but if it goes like too high, I think we should not call it a plate. Rather, we should call it a block, right?
আচ্ছা
I'm not sure about the threshold thickness, okay? But if it is excessive, then we should call it block.
ওকে।
Block.
Yes. Okay. Any more question from the audience? Now I have a question for Russell Khan.
Yes, sir.
Like, what is the significance of clearance during sharing?
শেয়ারিং সময় স্যার যদি ক্লিয়ারেন্সটা না রাখা হয়, তাহলে স্যার হইতেছে এই যে ইলাস্টিক রিজিয়নে যে ব্যান্ডিংটা হবে, সেই ইটা পাবে না তো স্যার, জায়গাটা পাবে না।
What happens if the clearance is too small and clearance is too large?
লার্জ হলে বার তৈরি হবে, আর যদি হইতেছে তাহলে হইতেছে লোড কাজ করবে না, যদি হইতেছে থিকনেস কম হয়।
I don't think like that. Is there anyone who can explain this? Like, if clearance is too small for blanking operation, for example, blanking or punching, if the clearance is too small, what will happen? And if the clearance is too large, then what will happen? Anybody? Rana?
No clear idea, sir.
Okay. Okay, let me explain. If the clearance is too large, then instead of sharing action, the sheet metal actually produce a blank. Sorry, not the blank. Sheet metal will actually bend, and it will produce a cup. Did you understand? Let me.
Yes, sir. I understand.
Hmm.
If the clearance is greater than the required thickness, then it will be bent, not cut.
Yes, it will actually bend. For example, if I must draw, let's say I have a die here and I have a punch. Sorry, I have to use it. But can you see my drawing?
Yes, sir. Clear, sir.
yes yes
Let's say the clearance here is too large. Okay, the clearance is too large, and there is a sheet metal placed in here. The stock is placed in here.
Sir, is it called drawing?
No, if the clearance is too
Punching.
large, I was talking about either punching or blanking.
Mm.
In case of blanking or punching, in either case, if the clearance is too large, instead of sharing action in this place, it will become like cup. Okay, it will be like a cup. And if the clearance is too small, then you will need a excessive amount of force. Okay, and there will be compression. It will cut it. It will produce bar. Okay, it will produce bar, like the edges will be
Sharp.
like this. Okay, like this. Actually, this is called bar. Edges will be like this, and it will require too much force. Okay, if the clearance is too small. So that is the significance of the clearance in case of blanking and punching. And if you talk about the drawing, then you need to have the larger clearance to draw something. Okay.
But in this figure, in the die punch is look like drawing.
Yeah, because it should be infinite plate, right?
Yes, sir. Then it will call punch or blanking.
Then it will look like the punching or blanking. Okay.
Yes, sir.
Okay. So where is your partner?
Maybe he will join.
Will join when? It's been like 30 minutes. Our class has started, and he's not here. So I think, Tuhin, can you continue your presentation?
Yes, sir. I think I can.
You can start. Let's see how long it takes. Okay, Tuhin, go ahead.
Sir, I am trying to share the screen.
Yes, sure. Okay, thank you, Russell Khan, for your presentation. It was nice, but was a little bit fast. And you could have taken some more time to explain some things. Okay, but however,
Yes, sir.
it was good. Okay,
Thank you, sir.
thanks for your presentation.
Sir, can you see my screen, sir?
Yes, we can see your presentation. Yep.
So can I start?
Yes, go ahead.
Good evening, sir, and my fellow classmate. I am Tuhin Goldar, and today I am going to present on water jet machining. Objective of my presentation is to introduce water jet machining, and I will also introduce the abrasive water jet machining. After that, I will follow the water jet machining only, and where I will discuss about principle of water jet machining and the equipments used, cutting rate parameters for water jet machinings and applications, advantages and limitations of water jet machining. What are water jet machining and abrasive water jet machining? In both cases, there is a requirement of very high pressure of water. The pipe is carrying very high pressure water. The pressure is very high, and it will be as high as 4000 bar. It is a very high pressure. If we consider an overhead tank on a 3-story building top on, then we will get 1 bar pressure on the ground floor. If we convert it to a stress unit, it will be around 400 megapascal. Most of the alloyed carbon steel has shear strength less than 400 megapascal. So this is a very high pressure. There is another thing which is abrasive water jet machining. Why abrasive water jet machining is required? Because only water jet machining can cut soft metals and thin metals, but to cut thick and harder metals, we need abrasive water jet machining. If we look at the figure B and D, there is a small point which is the abrasive connection point. For B, it is line 2, and for figure D, it is line 3. So there is abrasive coming and it mixes with the water. In the figure D, the item 2 is a orifice. Orifice, what does the orifice perform? Orifice actually converts the pressure of water into potential energy. So once the water comes out of the orifice, the water jet is formed. After that, there is two types of thing. One can be water jet, so it directly comes out, which is figure A, and figure B and D is abrasive water jet machining. When it mix with the water jet, the abrasive mix with water jet, it also come through the nozzle and cut the metals. The velocity of the water when it passes the orifice will be around 1000 meter per second, and the exact velocity of the water jet can be obtained by Bernoulli's equation. Water jet machining can be divided into two groups. One is by using pure water and another is with water with stabilizer. When we use pure water, the when you use pure water and it comes from the orifice, then there is a water jet. But when it comes out of the nozzle tip, then there will be air entrainment into the water jet and it becomes a flare. So when the water jet becomes flare, its working ability will be reduced. To enhance it, we can add stabilizer. Stabilizer is something like a polymer chain with higher molecular weight. So this reduces the flaring and increase the efficiency. Now we discuss about the principle of water jet machining. The water jet machining involves directing a high pressure, high velocity water jet to a surface to be machined. The fluid flow rate is typically from zero point 0.5 to 2.5 liter per minute. So this is a small amount of water per minute, but when if we look at the tip sizes, which is the zero point 0.1 to zero point 0.3 millimeter, so this is very small. So zero point 0.5 to 2.5 liter water can serve for up to 1 minute. The kinetic energy of water jet after striking the work surface is reduced to zero. During that time, the bulk of kinetic energy, when it strikes the job, it converted into pressure energy. If the local pressure caused by the water jet exceeds the strength of the surface being machined, the material from the surface gets eroded and cavity is thus formed. This cavity is actually the cutting line or the machining. Water is the most common fluid used, but additives such as alcohols, oil products, and glycerol are added when they can be dissolved in water and improve the fluid characteristics. Equipment of water jet machine. Generally, a water jet machine consists of hydraulic pump, intensifier, accumulator, high pressure tubing, jet cutting nozzle, and a catcher. Hydraulic pump. Hydraulic pump is powered from a high power electric motor. It supplies oil at a pressure more than 100 bars to the intensifier. We'll discuss about the intensifier in next slide. Compressed oil drives a reciprocating plunger pump termed as intensifier. It also supports single or multiple cutting stations for increased machining productivity. Intensifier. Intensifier accepts the water at low pressure and expels it through an accumulator at higher pressure of 4000 bar. The intensifier converts the energy from a low pressure hydraulic water into a ultra high pressure water. The hydraulic system provides fluid power to a reciprocating piston in the intensifier center section. A limit switch is located at each end of the piston travel, signals the electronic controls to shift the directional control valve, and reserves the piston direction. The intensifier assembly with a plunger to each side of the piston generates pressure in both directions. As one side of the intensifier is in the inlet stroke, the opposite side is generating ultra high pressure output. During the plunger intake stroke, filtered water enters the high pressure cylinder through the deck valve assembly. After the plunger is reverses in the opposite direction, the water is compressed and exits ultra high pressure from the other end. There is a general arrangement of the intensifier, the hydraulic pump, and the accumulator. Accumulator. Accumulator maintains the continuous flow of the high
Student,
pressure water.
when- sorry
Yes,
to
sir.
interrupt.
Yes.
Can you, when you are describing any components, and if you have a diagram, I think it's better to describe it using the diagram so that you can understand it much better. So, do you have
Sir,
any image for
actually,
accumulator? Do you have image for accumulator?
sorry, sir, I can.
Uh,
Sorry, sir, I can't hear you clearly.
do you have the image for accumulator on the next slide?
So sir, not actually, sir. I only have the image here on that slide.
Okay. Okay, then go ahead.
Accumulator contains it maintains the continuous flow of high pressure water and eliminates pressure fluctuations. We need a continuous pressure on the nozzle tip of the water jet. It reserves pressure like a flywheel of an engine reserves the energy for a steady rotation. Here it provides steady pressure to the water feed to the cutting nozzle. It relies on compressibility of water in order to maintain a uniform discharge pressure and water jet velocity. When the intensifier position changes its direction, because the intensifier is a reciprocating pump which move forward and aft, or we can say both sides. The high pressure tubing, the high pressure tubing is carrying the high pressure water. It transports pressurized water to the cutting head from the accumulator. The typical tube diameter are 6 to 14 millimeter. This the tubing also allows the flexible movement of the cutting head for a programmed machining or manual machining also. The Z cutting nozzle. Z cutting nozzle provides a coherent water jet stream for optimum cutting of low density soft material that is considered non machinable by conventional methods. Nozzles are normally made from synthetic sapphire. About 200 hours of operation are expected from a nozzle, which become damaged by particles of dirt and accumulation of mineral deposits on the orifice due to the erosive water hardness. A longer nozzle life can be obtained through multi-stage filtration, which removes undesired solids of size greater than 0.45 micrometer. The compact design of the water jet cutting head promotes integration with motion control system ranging from two axis to a sophisticated multi-axis robotic installations. It also has CNC controller to move the nozzle for a pre-designed shape. The catcher. When the water jet cuts the jobs, then the debris and the cutting pieces also the residual velocity of the water comes from the other side of the job. So we need a catcher. This is acts as a reservoir for collecting the machining debris entrained in the water jet. Moreover, when we there is a cutting of a very high speed water jet, the noise level is very high, so it has to be decreased. So this catcher also decreases the water sound level. The water jet cutting rate parameters. The water jet nozzle have to travel at a certain speed in different directions, two directional or a multi-directional position. So this depends on the quality of the nozzle, the type of jet fluid, and the workpiece properties. The jet nozzle. The jet nozzle, there are few properties or parameters to be taken care of. There is a stand of distance. The stand of distance is the distance of workpiece and the nozzle tip. The nozzle tip normally have a diameter of zero point 0.1 to zero point 0.3 millimeter, and the distance is around 2.5 to 6 millimeter for general purpose. For material used in printed circuit boards, it may be increased to 13 to 19 millimeter. If the stand of distance is larger, then the smaller would be the depth of cut. Depth of cut is the uh, thickness of the workpiece or the depth we want to cut on the workpiece. When cutting fiber reinforced plastic, reports showed that the increase in machining rate and use of a small nozzle diameter increase the width of the damaged layer. The jet fluid. The fluid used must possesses low viscosity to minimize the energy losses and should be non-corrosive, non-toxic, common and inexpensive. Water treatment is necessary to confirm the above parameters, and also sometimes we have to add stabilizers or additives. The workpiece. Brittle materials is hard to cut by water jet, while ductile ones will be cut well. Material thickness range from 0.8 to 25 millimeter or more can be cut using water jet machining. Table below shows some cutting rates for different materials and different thicknesses. Applications of water jet machining. Water jet machining is used on paper, cloth, leather, rubber, plastics, foods, etc. Sometimes, and for food industry, it cuts normally frozen foods. It is a versatile and cost-effective cutting process that can be used as an alternative to traditional machining methods. It completely eliminates heat-affected zones because there is no heat generation, only high speed of water jet nozzle. Toxic fumes, there is no toxic fumes, there is no recast layers, work hardening, and thermal stresses. It is the most flexible and effective cleaning solution available for a variety of industrial needs. In general, the cut surface has a sandblast appearance. That means the surface is also clean, cutting surface. Moreover, harder materials exhibit a better edge finish. Typical surface finishes ranges from 1.6 micrometer root mean square to very coarse depending on the application. Tolerances are in the range of minus 25 to 25 micrometer on thin material. Both the produced surface roughness and tolerance depend on the machining speed. If we have to adjust the machining speed based on the water velocity available or water jet velocity available. Advantages of water jet machining. It has a multi-directional cutting capacity. Water jet machining is a relatively fast process. No heat is produced. Cuts can be started at any location without need of pre-drilled holes. For cutting with gas or plasma, we have to pierce a hole or have to cut from outside of the defined line. So this is not required for water jet machining. It can directly start cutting. Wetting of the workpieces material is minimal. Only the surface, the edges where the water jet is cutting, there will be some wetting surfaces. There is no deflection to the rest of the workpiece. No heat is generated, and for thin material, if we cut it with gas cutting or plasma cutting, due to heat generation, sometimes it distorted or not in the shape. Sometimes it's bent, but for water jet, it will not bend. The bar produced is also minimal. If we adjust the high water jet, for certain materials or certain job pieces, then the bar will be reduced, which is generally occurs at the other side of the objects. The tool does not wear, therefore does not need sharpening. The process is inherently safe. Hazardous airborne dust contamination and waste disposal problems that are common when using other cleaning methods are eliminated for water jet machining. There is multiple head processing. Simple fixturing eliminates costly and complicated tooling, which reduces turnaround time and lowers the cost. Grinding and polishing are eliminated also, reducing secondary operation cost. The narrow curve allows tight nesting when multiple parts are cut from a single bung. It is ideal for roughing out material for near net shape. This is ideal for laser reflective materials such as copper and aluminium. It allows for more accurate cutting of soft material. It is also cheaper than other most machining options. Limitations. Very thick parts cannot be cut with water jet cutting and still hold dimensional accuracy. If the part is too thick, the jet may dissipate some and cause it to cut on a diagonal or have a wider cut at the bottom of the part than the top. It can also cause a rough wave pattern to the cut surface. The tolerances deteriorate with material hardness and thickness also. This is the end of my presentation. Thank you for your patient hearing. And now if you have any questions, I'm here to answer.
Okay, thank you, Tuhin. And do you have any question for Tuhin? Any question from audience? No. Okay, then can you please go back to the advantages of water jet machining?
Sir, yes, I'm going, sir. This is the advantages, sir.
Okay, in here, no heat is produced. Can you explain this one?
Sir, because the water is coming out from the jet and this is a pressurized water. So when this kinetic energy diverges to a pressure energy and it erodes actually the surfaces where we want to cut. So the water is also used as a coolant for that case. So no excessive heat is generated.
That's right. And also there was something like heat affected zone. Where
Yes,
is
sir.
that in?
Sir, as the heat generation is minimal, sir, so
So
there will be no heat
no
affected
heat,
zone.
heat affected zone. Yes, definitely. And can you go to the next slide? Next one. Uh, and it is ideal for laser reflective materials, copper and aluminum.
Yes,
Can
sir.
you explain this one?
Sir, I'm not sure about the laser reflective materials, but I got it from a source, from internet. But the laser, sometimes the laser cannot cut. I think I'm not sure about that,
Okay,
but it's
you're
some.
right. The copper laser cannot cut copper and aluminum because the laser ray are reflected.
Yes, sir. Yes, sir.
So mm, it takes huge amount of energy to cut copper and aluminum in a special arrangement for cutting them. So water jet would be really nice. And another thing is that in the application, can you go to the application?
Yes, sir.
Applications in here, you did not mention any metal, did you?
Sir, the water jet can cut the soft metals. Sorry, sir, I didn't add here, but the soft metals it can cut, and which is smaller in thickness.
Yep, that's right. Okay, that was a nice
Ductile
presentation.
metal.
স্যার আর একটা কোশ্চেন আছে স্যার
Yes, yes, go ahead.
স্মলার থিকনেস বলতে থিকনেস রেঞ্জটা কত
It's actually not a range. It depends on the hardness also. So the this depends on the pressure energy that can erode. So if the thickness is higher and the lower part will be not cannot be cut, and there will be a inclination, or the surface will be blurry and it cannot cut easily. Also, the water reduces is pressure easily. So I'm not I don't find any limitations for thickness.
Yes, you are right, Tuhin. Actually, for the water jet machining, if the material is soft, for example, if you want to cut bread, okay, the
Yes,
morning bread, then thickness can be like very high, okay, 5 inch or 6 inch, it can cut through 5 inch,
yes,
okay.
sir.
But if the material is like plastic, then the thickness will be smaller.
Yes, sir. Like plastic, polymer, the
Well,
thickness should be less.
thermal reinforced composite. In that case, the thickness will be lower. So it depends on the softness of the material. The thickness
Yes,
actually depends on the softness. Okay.
yes, sir. Yes, sir.
Okay. Any other question from audience? Then can
Yes,
you go to the
sir.
okay?
Sir, water jet machining in which fields it is using at present in maybe
The for
in
example,
Bangladesh?
in the food industry, they actually use water jet machine. Okay, for cutting the foods,
Yes, sir.
the bread,
Um,
cakes, something like that. It's very safe. You know, the
Yeah.
water is very safe.
Also in the textiles and leather
Plastics,
industries.
yeah, and also sometimes in the industries they use it, and also for cutting plastics or fiber reinforced composite materials, they use this method because it is safe. Okay, it does not produce much heat. There is no heat affected zone, and you can obtain sharp cut. Okay, so that is why this machining process is used. Okay, any other question?
sir, if water is used, then there may be corrosion or something like that.
Corrosion to
So
which part you are thinking?
maybe metal, soft metal, if soft
The
metal is used.
metal, for all the cases there will be corrosion if we use the gas cutting or plasma cutting. There is a water bed also, which is the catcher we can describe as. But this corrosion is always there when it is on the environment. There is always a corrosion. But for the water jet cutting, it is only for the mainly for the edges and a very small area. So this is not significant, and the cutting is very fast, so we can easily or very fast we can remove the cutting pieces for the further assembly or production processes.
Abdullah, actually, if
Sir,
you want to compare it with the gas cutting, the water jet cut machining and gas cutting, then in the case of gas cutting, you will get much more affected zones like the production of oxides.
Yes,
Okay, which is kind of corrosion. Okay, but in the case of water jet machining, you will not get that. Okay, and once the cutting is done, you can clean it, then you can dry it, and then you can get rid of
yes, sir, sir. Extra dry needed.
then but in case of braids or something like that, the cutting is so smooth and so fast that there is no water particle left,
yes, sir. This is very high
Hmm.
speed water, and it will directly goes below
Yeah, it's collected in the what is it,
catcher.
scatter,
Yeah.
Sir, is there any formula for pressure for different types of material?
Yeah, there is different formulas. It is depending on uh, the softness or how hard the metal is. So we have to adjust it with the thickness, and you have to adjust the pressure of the water jet.
okay. Did you get your answer, Russell?
Yes, sir.
Maybe it's not shown in the slide, but
Yes,
there is limit like that. If you want to cut the metal, then you will need a very high pressure, and also it will depend on the thickness. So there are a lot of ways to optimize the cutting. Okay. All right. Can you go to the third or fourth slide? Fourth slide maybe, or the intensifier, the image of the intensifier.
yes, here.
Yep. Can we explain this one from this image actually?
Sir, there are two inlets of the to the intensifier.
Hang on. Uh, is it just a dual side reciprocating pump, right? That
Yes,
means
sir.
it's what do you call it in the in fluid mechanics?
Sir, it's a reciprocating pump.
Yeah, it's a reciprocating pump, but if it has two reciprocating pump has two type of reciprocating pump.
A
One
double head, sir. Double head
double head,
reciprocating
yes,
pump.
double head. Something like that. Yes.
Hmm.
Okay, I got it. All right. Okay, thank you very much for your presentation. It was really nice, and you did give some time to organize the presentation. So I really appreciate that. And
Thank you, sir.
in some cases, you explained really well. And the only thing is that sometimes if you describe the things, too many things,
Sir, I should add some pictures, sir. I
you
understand
should
it's the
accept
limitation.
this,
Yes,
okay?
sir.
Sometimes there are too much text. It's really hard to read, but,
Yes, sometimes it will.
overall presentation, it was nice. Okay?
Thank you, sir.
Thank you very much. Okay, where is our Tanjir, Mr. Tanjir?
Sir, I'm Tarin, sir. Um,
Is he here?
Sir,
yes,
Tarin
sir,
আর আমি
I'm
একই।
Tarin, sir. I'm preparing for,
You wanna present today, or
sir,
it's on already 1 hour today. So how about next day,
sir,
next Saturday, Tarin?
next Saturday, sir, no problem, sir.
Okay, I think in the next Saturday you can present, or maybe after my lecture on Thursday. On Thursday after my lecture, you can present.
Okay, sir, no problem, sir.
And today the Mr. Tanjir is absent, right?
Sir,
Yes.
yes, sir.
Did you have
Anjir
a
Karim. Yes, sir.
talk with Tanjir Russell
Yes, sir. Anjir Karim.
or Amjir Karim, right? It's Amjir Karim. So what did he say? Did he want to come, or
Sir, he didn't call me. That's why I don't know what is his intention.
okay, that's fine. Then we'll close for today, and next class will be on Thursday 7:30. Okay, I'll see you all there.